Hi, welcome to Tammy the Tutor. Today we are in CC2, lesson 1.2.2. The first problem is number 70. Imagine that you have a bag containing 10 marbles of different colors. You've drawn a marble, recorded its color, and replaced it 50 times with the following results. So 9 times you pulled out a purple marble, 16 times an orange, 6 times a yellow, and 19 times a green. Make a prediction for how many marbles of each color are in the bag. Okay, so the first thing you want to do is let's count up the total amount of draws, which means we need to add, I'm going to write, there's 9 purple, 16 orange, 6 yellow, and 19 green. So that would be 15, 30, 3, 4, 5. Okay, so there are 50 total draws here. Let's create a fraction for each color. So 9 times they drew a purple out of 50 times that they drew. 16, I'll put the color on top so I can keep that straight. For yellow, there was 6 50ths, and then green was 19 out of 50 draws. Okay, so once you have this fraction here, all you need to do is divide. Remember, you've been told by now that this fraction bar just means divide. So get your calculator out, and 9 divided by 50, and I did this beforehand so it went quicker, is 1800ths. The orange is 3200ths. It's 1200ths. And then 3800ths. Okay, we're almost there. Now, all we need to do is multiply each of these times 10, and then we'll round it to the nearest whole number, and you'll see what happens. And if you understand the powers of 10, you know that when you multiply any number times 10, all it really does is moves the decimal point 1 hop to the right. So that's just going to turn this into 1.8. This turns this into 3.2, 1.2, and 3.8. All we need to do now is round these numbers to the nearest tens place. So 1 and 8/10 will round to a 2. This rounds to a 3, a 1, and that rounds to a 4. So remember, the original question says, try to predict how many of each marble was in the bag. Well, they said there were 10 marbles of different colors in the bag. Well, if you count up what we just came up with, 4, 5, 6, 7, 8, 9, 10. So that would make sense. We predict that there must have been 2 purples, 3 oranges, 1 yellow, and 4 greens. Okay. '71. A fair number cube with the numbers 1, 2, 3, 4, 5, and 6 is rolled. Basically, it's a dice, or a die if it's 1. What is the probability of getting an even number? Okay, well, just look at all these numbers. How many of them are even? So you have 2, 4, and 6. So out of 6 numbers total, 3 of them are even numbers. So your chance of getting an even number is 1/2. B, what is the probability of getting a factor of 6? So let's look at all of the factors of 6. You can get there by multiplying 1 times 6 or 2 times 3. So these 4 numbers right here are all the factors of 6. So out of 6 total numbers, there are 4 that are factors of 6. And again, if you can reduce, you need to always reduce. So we're going to divide both of these by 2, and that reduces down to 2/3. '72. Ramon is saving $7.75 per week to buy a new cell phone. The phone he wants costs $125. For how many weeks will he need to save his money? First, estimate your answer, then figure out the actual number of weeks. Okay, this is just a division problem because if he's saving almost $8 a week, we just need to, how many weeks until that $8 turns into $125? So they just want us to estimate first. So did you hear what I just said? I didn't say $7.75. I'm rounding it up to $8 because that's way easier with estimating. Rounding is a huge part of estimating. And so in my head, I am trying to mentally decide how many times 8 can go into 125. And it looks like, I don't know, around 15. I know that's not exact, but that's the whole point of estimating is we just want to get close. It doesn't have to be perfect. So my estimation is 15 weeks. You guys may have a different answer and you might round things differently. Maybe you rounded 125 down to $120. Whatever. Everybody thinks about it a little differently. So now let's figure out exactly how much. So let's do 775 goes into 125. Well, first of all, when you're doing division, you can't divide if this number right here, it's called the divisor, if it has a decimal. You need to make that a whole number. And you can do that by making 2 hops to the right. Now that is a whole number. But the only reason it's okay for me to do that is if I balance everything and I come over here and I do the exact same thing to this one. Here's our decimal and I'm making 2 hops to the right and I'm going to fill that in with zeros. So basically I just have 2 whole numbers now. So you just need to ask yourself how many times does 775 go into, let's see, here we go, 1,250. We'll cut it off right there. And it would only go in once because if we doubled 700, we're at 1,400. And so we know that's too much. So it just goes in once. And then 1 times 775, subtract, would be 14. That would be 11. Okay, and then we need to bring down our next number. So now we need to think of how many times that goes into 4,750. So I'm going to estimate 775 to be 800 because 8's an easier number to do. So thinking about how many times does 8 go into 47. I'm going to try, remember we had estimated 15. I don't think that's enough. I'm going to try 6 this time. 6 times 5 is 30. 6 times 7, 42 plus 3 is 5. 6 times 7, 42 plus 4 is 46. Okay, we got pretty close. So we need to subtract. We have 100 left over. So, you know what, we're going to keep going. We're going to add a decimal 0, and then I can bring that next 0 down. But also I'm going to come up here really quickly and I'm going to bring my decimal up so I don't forget. So 775 can go into 1,000 once, and that's this. Okay, so if you look at what the problem's really asking, this is how many weeks will he need to save his money? So we already know it's 16 and something. So we just need to decide, are we going to estimate that it's going to take him about 16 weeks, or is it so far into the 16 that it's almost 17 weeks? Well, just by putting this 1 right here, we already know that that is going to round that 16 to a 16 rather than rounding up to a 17. So we really don't need to go any further. So it's going to take him about 16 weeks. And if you want to be super technical, you can say it'll take him 17 weeks, but then he'll also have a little bit extra money left over. Okay. Okay, we're on 73. If 18 inches is equal to 1.5 feet, how many feet is a 36-inch board, a 72-inch board, or a 144-inch board? I'm going to make a ratio table with this. It just looks like a bunch of equivalent fractions, and I love seeing the relationship between these kind of numbers. So here's what I think I'm going to do. I will do I'll do the 1.5 on top, 1.5 feet, and I'll just put over here that this is representing feet. And that is the same thing as 18 inches. Okay. Now, see how the feet is on top and the inches are on the bottom? Right here it says how many feet, so we don't know what that is, but how many feet is a 36-inch board, a 72-inch board, and a 144-inch board. So the reason why my instincts told me to make a ratio table is because when I was reading the question, I already noticed a relationship between this number and this number, this one and this one, and this one and this one. It was pretty easy to tell that if I double 18, I get 36. Okay, do you see this pattern? Now if you double 36, you get 72. And yep, if you double 72, you get 144. Now watch how easy a ratio table makes this. If I double 18 to get 36, and these two things are equal, that means I can double this to see how many feet this should be. So what is double 1.5 feet? That would be 3 feet. Again, if I can double 36 to get 72, then I can double 3 and get 6 feet. If you can double this to get this, you can double this to get this. And then if you really want to go back and check your work, think about this for a second. How many inches are in 1 foot? 12. Well, wouldn't it make sense that 3 feet then is 3 times 12? That would be 36 inches total. Okay. Really what we're doing is we're multiplying the top number times 12 to getting the bottom. See how the ratio, no matter which way you go, horizontally or vertically, the pattern is the same. So if you're looking at it this way, 1.5 times 12 is 18. 3 times 12, 36. 6 times 12, 72. 12 times 12, 144. Or times 2, times 2, times 2. Okay? $74. Copy the incomplete axes below and write the missing numbers on each one. Okay, so this is basically just a number line that is vertically written instead of horizontally written. And you're used to seeing them horizontally, but really there's just no difference. I actually like vertical ones sometimes better. So we did this recently with horizontal number lines. We had to figure out how they were scaling it and what they were adding each time, and we filled in the missing numbers. The difference is on those, they usually had 2 numbers right next door to each other, so we were always able to subtract or to add to see how much each hop would be. But if you notice, we're basically given 0 for all of them, and then sometimes only one other number with all of these missing ticks in between. So let me show you the trick of how to do this. On A, well, first of all, on A, you're probably looking at it and you're automatically assuming it's counting by 20s, and your instincts are great because, yes, it is. But I want to show you something that you can do for all of these no matter what that will always work. So all you need to do is pick one of the numbers. You can do it with 100 or you can do it with 60. It doesn't matter. I'm just going to do 60. I am going to do 60 and then the 0. Okay. How many hops are between these two numbers? Okay, so if you're starting at 0, that's 1, 2, 3. So what's happening is 60 is being divided by 3 equal parts. Well, 60 divided by 3 is 20. So that means each of these hops represents a 20. So if that's 20, another 20 added to that has to be 40. 20 added to 40 is 60. 20 added to 60 is 80. And 20 added to 80 is 100. Okay, so try it on this one. How many hops is between the 0 and the 60? 1, 2, 3, 4. So you're dividing 60 by 4 equal parts. And when you divide 60 by 4, you get 15. So from here to here is 15. Add another 15, you're at 30. Add another 15, 45. Add 15, you're at 60. Add 15, you're at 75. Okay, look at C. There's 1, 2, 3, 4 hops between 0 and 100. So 100 is being divided by 4. Okay, that's probably one of the easiest numbers in your head that you know very well. So 100 divided by 4 is 25. So that would be 25, 50, 75, 100, and then this one's 125. Okay, there are only 2 hops between 0 and 100, so 100 divided by 2 is 50. And there you go. These are actually super easy as soon as you understand how to deal with them, and it works every time. Okay, looks like we're done with today's lesson, guys. Thanks so much. See you next time.